Dear students, welcome to today's class. Last 3 days onwards, so we are explaining about the very important chapter, that is set theory. Okay, so here today class I am going to explain very few very important concepts which are very useful even to solve the problems of probability also. Probability problems also can be solved using set theory. Okay, now see this concept, first concept here. The first one is, if first concept, if A subset of B, then what are the things that is going to be happen? Let us see one by one. First thing is, I am going to draw the Venn diagram. Okay, now A subset of B. So this is the set A and it is B. Of course, this is a universal set, A subset of B. That means the elements of all the elements of A belongs to B. Then we call it as A subset of B. See here how many results we will get. When A is subset of B, the first result what we are going to get is A union B is equal to B. See the diagram, A union B is equal to B. Second one is A intersection B is equal to A. Third result is, that means A intersection B, what is the common of A and B? A only. Next one is A minus B is equal to, so that means when A is subset of B, A minus B will become a null set. That means all elements will get cancelled. Next one is B minus A is a finite set. Some finite. Of course, if A and B are non-empty sets, B minus A is a one finite set, you will get some elements you will get. Okay, now, right. Next one is, if you observe, next one is N of A union B is nothing but N of B. Next one is N of A intersection B is nothing but N of A. Understand? So next one is N of A minus B is equal to 0. The number of elements in A minus B is 0. Next result is N of B minus A is equal to a finite number, finite natural number, if you say that number, finite number, any some elements 5, 6, 7, 10 like that you will get. So these are the very important thing that you should learn, understand. And one more thing that is a very important is, if A is subset or equal to B, then is B complement is subset or equal to A complement. If A is subset or equal to B, then B complement is subset or equal to A. When all these things happens, when A is subset of B. So these type of basic fundamental concepts you should learn. Okay, now, right. Let us see another concept. What is that? When A and B are disjoint sets. So one by one I am telling. First one is A is subset of B. Second one, A and B are disjoint sets. Third one is A and B are overlapping sets. Next I will go for 3 sets, A, B, C. Okay, na? So let us go to next concept. Let us see the second concept. Second concept is, when A and B are disjoint sets. A and B are disjoint sets. When A and B are disjoint sets. Okay, now let us see that. What is meant by disjoint set means there won't be any common element belongs to both A and B. There won't be any common elements. For example, so this is a universal set. This is A and B. A, B. So this is called disjoint sets. Let us see one by one what happens. The first one is A union B is equal to a finite set. You will get finite set. The elements which belongs to A and B, you will get a finite set. But what about A intersection B? It is a null set. A intersection B means there won't be any common element. which belongs to both A and B. There won't be any common elements. Next one, A minus B is equal to A. Next one, B minus A is equal to B. B minus A is equal to B. Next one is, so if you observe, B is subset of A complement. That means what? A complement means what? Outside of A, outside of A, outside of A. So B is subset of A complement and A is subset of B complement. Then also we can say that A and B are disjoint sets. Then also we can say disjoint sets. Next one is cardinal number. Next we will come to cardinal number. What is n of A union B? A finite value. Finite value you will get. Next one is what is n of A intersection B? Nothing but 0. A intersection B is null set. N of A intersection B is 0. Okay, na? Right. Next one, seventh one, n of A minus B. N of A minus B is equal to n of A. N of B minus A is equal to n of B. So these are the things that happens when A and B are disjoint sets. Okay, na? So like that, in all the cases you have to learn one by one. So you have to maintain a separate notebook for this and you have to write down all these concepts. Okay, na? So you have to read these concepts one by one. That means sometimes you may be asked in like that. If B is subset of A complement and A is subset of B complement, then he will create one problem. Whenever it is given that B is subset of A complement, then we have to say that A and B are disjoint sets. Understand? Now, let us see that if what happens if A and B are overlapping set. Overlapping set means what? There exists at least one common element for both A and B. Okay, na? So let us see that. When A and B are overlapping sets, the third concept is A and B are overlapping sets. See what happens. A and B are overlapping sets. Let us draw the Venn diagram for this. This is a universal set A and B. So this is a A and B. Overlapping set means there exists at least one number which belongs to both A and B. So if you observe here, so the Venn diagram is, so what is this shaded part, black part? This part is called, this shaded part is A minus B. Understand? What is this shaded part? This part is B minus A. Blue shaded part is B minus A. That everybody knows. Now what about this part? What about this part? This is A intersection B. Everybody knows that. So from this we will get a number of results. Number of results we can get from this concept. Okay, now the first one, what about A union B, A intersection B, A minus B, B minus A? When A and B are two non-empty sets and moreover they are overlapping set, all these four are some finite sets. Some finite sets, some value you will get, some finite set, there are some elements you will get. So there won't be any null set unless otherwise A and B are two non-empty sets. The second one is, what you have to see is, if you observe A minus B, first to see here A minus B. How can you write down this A minus B? A minus B means this part. Up to here A minus B. So this part, black part. This A minus B, how you can write down A minus B? So see, different ways. So this is the common, from A you have to subtract A intersection B. That means A minus of A intersection B. A minus of A intersection B. And the second one is A intersection B complement. That means B complement means what? Outside of B. outside of B and A, their intersection part is A minus B. And one more thing is you can write it as a total A union B, total A union B minus B, total A union B minus B. If you take B outside, then also it is A minus B. Understand? So in these three ways you can write it as A minus B. So A minus B is same as A intersection B complement. So these concepts are very, very useful for your JEE mains examination in the chapter statements. Statements and sets, one concept is there. From that you will get one sure question. There these concepts and formulas are very, very important. Okay, now next one is B minus A. What about B minus A? B minus A means blue part. This is a B minus A. Then what about B minus A means what? Total B minus A intersection B. Total B minus A intersection B. That means total, this is a B. From this you subtract A intersection B. Then you will get B minus A. This is B minus A is same as A complement intersection B. A complement intersection B. That means outside of A and B. Outside of A and B, their intersection part is equal to. And moreover, A union B minus A. Total A union B. If you subtract A part, then you will get B minus A part. Okay. So these are the things, and some more things are there. So let us discuss. Total A union B. How you can write down A union B? Total A union B can be written as A minus B union A intersection B union B minus A. This way also you can write down. A minus B union A intersection B union B minus A. Like that is also you can write down. Next thing is this A minus B union B minus A. This is nothing but A delta B. A minus B union B minus A is nothing but A delta B. That is symmetric difference of A and B. This is same as A union B minus A intersection B. See here, A minus B means what? Black part. B minus A means what? Blue part. Their union means what? Except total, except A intersection B, except A intersection B, everything except. That's why A union B minus A intersection B. Okay, now right. Next from this, it is clearly it is there. You can say that A is subset or equal to A union B. A is subset or equal to A union B. That means A union B means full part. In the full part, A is the one part. That's all. And B is subset or equal to A union B. B is subset or equal to A union B. A union B means full part. In that, B is one of the subset of the A union B. Okay, now right. And one more thing is A intersection B is subset or equal to A intersection B. This part is subset or equal to A. And the same time A intersection B is a subset or equal to B. A intersection B is subset or equal to B. A intersection B is subset or equal to B. Understand this. And one more thing also you can write down. One more thing is what? This black part is A minus B. This red part is A intersection B. What is their union? A intersection B. A minus B union A intersection B is nothing but what? A. This is also one result. Again, this blue part is, seventh one this blue part is B minus A union. What is this red part? A intersection B. Together it is called B. Understand this? So these are the results from you can get from this diagram. This diagram you will, these are the things that you have to conclude from this. Okay, now let us see the cardinal number of the sets, cardinal number. So that means n of A union B, n of A intersection B, n of A minus B. What happens? Let us see that. Dear students, let us see problems related to cardinal number. Cardinal number. Cardinal number of the set. What is meant by cardinal number? Means what? The number of elements present in a set is called the cardinal number. Number of distinct elements. So the first one is n of A union B is equal to, this is nothing but n of A plus n of B minus n of A intersection B. For this also proof is there. So n of A union B means the number of elements present in total diagram. That means A union B means what? N of A. So this is n of A. See here, n of A means what? So you are counting A. That means you are counting A intersection B also. Plus n of B. That means you are counting B. You are counting B. That means again you are counting A intersection B. You are counting A intersection B. That means A intersection B is counted 2 times. A intersection B is counted 2 times. That means to make into equal, you have to subtract 1 time. That's why. So n of A union B is equal to n of A plus n of B minus of n of A intersection B. Okay now. Right, if they are disjoint sets, this won't be there. N of A intersection will become 0. Second one is, what is n of A minus B? N of A minus B. A minus B means what? So this is a black part. Total A minus A intersection B. That means n of A minus n of A intersection B. From total A, you subtract A intersection B elements. Enough. Next one, n of B minus A is equal to n of B minus n of A intersection B. B minus A means what? This is a blue part. Blue part. If you want to counter the number of elements in this blue shaded part, so total B minus A intersection B. Total B minus A intersection B. That's all. Number of elements belongs to B minus the number of elements belongs to A intersection B. So next one. And the next one you will get here is and n of A complement intersection B complement. Yes. N of A complement intersection B complement means what? Coming to the De Morgan's laws. That means A complement intersection B complement can be written as A union B whole complement. So this is nothing but n of mu minus n of A union B. N of mu minus n of A union B. That means the number of elements present in universal set minus A union B will give A union B whole complement. Okay na? So afterwards you know that what is A union B, how to find out A union B. Understand this. Okay. So let us see some more formulas. Let us see some more formulas here. N of A intersection B, number of elements present in A intersection B. So what is A intersection B? So whenever it is saying that A intersection B means this is a minus B. From A you have to subtract A intersection B. From A you have to subtract A intersection B. That means you can write it as n of A minus n of A intersection B. Otherwise, you can write it as n of A minus n of A intersection B. Otherwise, you can write it as n of A union B. That means from total A union B. From total A union B. If you want to find out A intersection B, so this is A minus B union B minus A. You can call it as A delta B. N of A delta B. Like that also you can find out. A delta B means what? That is n of A union B is equal to minus. A delta B means what? A minus B union B minus A. That is n of A minus B minus n of B minus A. Like that also you can find out. Again you can write it as n of A union B minus n of A minus B means what? A intersection B complement. A intersection B complement minus this is a complement intersection B. Like that, you can, by seeing that diagram, you can write a number of formulas from that. Understand? And so, these are the main formulas which we will get from the when A and B are overlapping sets. When A and B are overlapping sets. Okay. So I hope that you understand this concept. Let us go for next concept. Dear students, so far we have seen with the two sets. When the one set is a subset of another set. The second case is when A and B are overlapping sets, and the third case is A and B are disjoint sets, and a various number of cases we have seen. Okay, now let us see that what happens when three sets are given. Okay, the first thing is all the three sets are pairwise disjoint. What is meant by pairwise disjoint sets? Pairwise disjoint sets. What is meant by pairwise disjoints? Means no two sets are overlapping. So this is equal to A, and it is a B, and it is C. So these three sets are called pairwise disjoint sets. Understand? So in this, what you will get, so A union B union C is, you will get the number of elements which belongs to A or B or C, all the elements you will write. Okay. And A intersection B is null set, B intersection C is null set, A intersection C is null set. And A minus B is A only, A minus C is A only, B minus C is B only, C minus B is C only. Okay, now everything you know. But now coming to the formulas related to cardinal numbers, cardinal number. That is n of A union B union C is equal to how much? N of A union B union C is nothing but, since they are pairwise disjoints, n of A plus n of B plus n of C. There won't be any A intersection B, B intersection C, A intersection C. Okay, now, right. Now, let us extend this concept to some n number of sets. What is meant that let A1, A2, A3, so on, A and B, n pairwise disjoint sets. What is meant by pairwise disjoint? There are n sets are there. So this is a A1, this is A2, this is A3, A4, A5, A6, A7, A8, A9, so on. N number of sets are there. No two sets are overlapping. That means no two sets are overlapping. That means everything is different. Then what about n of A1 union A2 union A3 so on An is nothing but n of A1 plus n of A2 plus n of A3 plus so on n of An. Understand this, what is meant by pairwise disjoint sets. Understand, if two sets are there, if A and B also, if you disjoint sets are nothing but pairwise disjoint sets. Pairwise means no two sets are union. Their intersection does not exist. Okay. So this is about pairwise disjoint sets. Okay. If they are overlapping sets, what happens? Let us see. So dear students, let us welcome to now next concept, that is A, B, C are three overlapping sets. What happens? Let us see this. So this is a universal set, this is a universal set. So this is A, B, C, A, B, C. These three sets are called overlapping sets. So from this also, from here also you can get the number of things you can get. So here this part is A intersection B intersection C. This is A intersection B intersection C. Okay, now, and this part is so this up to here it is there, no? That part you can say that B union C whole complement intersection A. B union C whole complement intersection A. Like that you will get a number of results you will get. Okay, now, so this is also A intersection B minus C. This is A intersection C minus B. This is a B intersection C minus A. Like that you will get number of formulas you will get from that. Now I am going to the formulas related to cardinal number. So here the cardinal number formula is n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. So understanding this formula is also very, very easy. N of A union B union C means what? You have to count all the elements which are present in either A or B or C or both A and B, both A and C, both B and C, and A and B and C also. So here N of A means what here? So here N of A, this is A, N of A. N of B, again A intersection B you are counting, remember that. And A intersection B intersection C also you are counting. N of C means, so this is the part. So you are counting A intersection C and you are counting B intersection C two times. That's why one time you are subtracting. So when you are subtracting, your total you are subtracting this. When you are A intersection B you are subtracting this. When you are subtracting A intersection C, you subtracting this part. That means all the times you are subtracting. But you have to count, no. That's why you have to add one time N of A intersection B intersection C. So this is a very, very important formula that we have from this set. Okay, now next from this we have one beautiful formula we have, that is what? So this is the first one. The second one, number of elements which belongs to one of the sets A or B or C. This is given by. So these formulas are very, very useful while solving probability problems. Okay. So the number of elements which belongs to one of the sets, either A or B or C, it is given by the formula number exactly one of the sets belongs to exactly one of the sets. Exactly one of the sets is given by the formula N of, given by the formulas N of A plus N of B plus N of C minus 2 times N of A intersection B minus 2 times N of B intersection C minus 2 times N of A intersection B intersection A B B C C A C intersection A plus 3 times N of A intersection B intersection C. So this formula also very, very useful while solving the problems. Okay, now so let us see some more concepts. Dear students, now I am going to explain a very, very important concept that is useful for your competitive examinations. The concept is maximum and minimum number of elements in A union B and A intersection B. What is this? So let us take one example here. For example, A contains the elements 1, 2, 3. B contains the elements 3, 4 elements are there. So let us draw the Venn diagram here. A, B. So here 3 is the common element. So we can insert here 3. So here 1, 2, here 4. This is the thing that we have. Understand this. So here what is the maximum? N of A union B is equal to how much? N of A union B is equal to how much? N of A plus N of B minus N of intersection B. N of A means 3 plus N of B means 2 minus N of A intersection B is 1. That is equal to 3 plus 2, 4. 3 plus 2, 5, 5 minus 1, 4. 4 is your answer. You count here 1, 2, 3, 4, 4 elements are present. So what is the maximum element? What is the minimum number of elements that we can write in that maximum number of A intersection B, maximum number of N of A union B, all these things, how you can write and how you can count. This concept that explains. What is that? So let us say that N of A is equal to P, N of B is equal to Q. Let us say that A contains P elements and B contains Q elements. The first concept is minimum of N of A union B. Next one, maximum of N of A union B. Next one, minimum of N of A intersection B. Next one, maximum of n of A intersection B. Let us see that one by one. 1, 3 and it is 4. Minimum of n of A union B is nothing but the maximum value of PQ. The maximum value of PQ. The minimum number of elements that is present in A union B is nothing but the maximum value of P and Q. What is the maximum number of elements that can be present in A union B means P plus Q. What is the minimum number of elements that can be present in A intersection B is 0. The maximum number of elements that can be present in n of A intersection B is nothing but minimum of P and Q. Minimum of P and Q. Understand? So coming to here, here A and B are two sets are there. So what is the maximum number of elements that can be present in A and B is 4. Maximum number of elements that can be present in A and B is 4. Understand this concept? So this is a very, very important concept which is useful for solving some problems. Okay, na? So dear students, I hope that you enjoyed today's class. In tomorrow's class, I will stand before you with some problems which were given in previous year examinations. Okay, na? So until then, goodbye.